For any homework-related queries, call us at 1-678-648-4277. You can mail us at info@databasehomeworkhelp.com or reach us at https://www.databasehomeworkhelp.com. 1. Introduction. The purpose of this assignment is to provide you some hands-on experience with the SQL programming language. SQL is a declarative language, or a relational calculus in which you specify the data you are interested in terms of logical expressions. We will be using the PostgreSQL open source database, which provides a fairly standard SQL implementation. In reality, there are slight variations between the SQL dialects of different vendors, especially with respect to advanced features, built-in functions, and so on. The SQL tutorial at http://www.postgresql.org/doc/current/static/tutorials/ql.html, included with the Postgres documentation, provides a good introduction to the basic features of SQL. After following this tutorial, you should be able to answer most of the problems in this problem set. The last few questions may be a bit tricky. You may also wish to refer to Chapter 5 of Database Management Systems. This assignment mainly focuses on querying data rather than modifying it, though you should read the sections of the tutorial that describe how to create tables and modify records so you are familiar with these aspects of the language. We have set up a Postgres database server for you to use. You will need to use the Postgres client, PSQL. More details are given in section 3 below. 2. NSF grants database. In this problem set, you will write queries over recent research grants from the National Science Foundation, NSF, awarded to professors at several major research universities. The National Science Foundation, NSF, is a significant funder of academic research in databasehomeworkhelp.com. The United States. Researchers submit proposals to various programs, for example, the Info Integration and Informatics, 3, program in the Computer Science Engineering, CSE, Directorate is primarily responsible for funding research on database systems. Panels of peer reviewers, other academics in related fields, decide which proposals will be funded. After grants are funded, typical amounts range from $50,000 to many millions of dollars. They are administered by the university on behalf of the researchers. Researchers pay graduate students, postdocs, and staff, purchase equipment and supplies, and pay expenses, such as travel, from these grants. In this problem set, you will write a series of SQL queries using the select statement over a database of all recent, since the early, mid-1990s, grants awarded to MIT, Harvard, Carnegie Mellon, Stanford, and UC Berkeley. There are approximately 10,000 such grants, in all fields, not just computer science. Figure 1 is a simplified entity relationship diagram that shows the relationships, lines, between objects, entities, stored in the database. This is a popular approach for conceptualizing the schema of a database. We will not study such diagrams in detail in 6.830, but you should be able to read and recognize this type of diagram. Our database consists of 6 entities, grants, with their associated metadata, example amount of funding, start and end date, the researchers who work on them, etc., organizations, example universities, which receive grants, researchers who receive grants, programs run by the NSF that award grants, managers at NSF who run programs that award grants, and databasehomeworkhelp.com. Organization researcher program manager field grant name directorate name title abstract name address amount started ended supports figure 1, an entity relationship diagram for the NSF database. Fields, research areas, that describe high-level topic areas for grants. These entities are instantiated as a collection of 9 tables in SQL. The data definition language, DDL, SQL commands used to create these tables are as follows: create table orgs, ID int primary key, name varchar, 100, street address varchar, 200, city varchar, 100, state char, 2, zip char, 5, phone char, 10, databasehomeworkhelp.com. Create table researchers, ID int primary key, name varchar, 100, org int references orgs, ID, create table programs, ID int primary key, name varchar, 200, directorate char, 3, the top level part of NSF that runs this program, create table managers, ID int primary key, name varchar, 100, databasehomeworkhelp.com. Create table grants, ID int primary key, title varchar, 300, amount float, org int references orgs, ID, pi int references researchers, ID, the principal investigator, pi, on the grant manager int references managers, ID, started date, ended date, abstract text, create table grant underscore researchers, researcherid int references researchers, ID, granted int references grants, ID, create table fields, ID int primary key, name varchar, 100, databasehomeworkhelp.com. Create table grant underscore fields, granted int references grants, ID, fielded int references fields, ID, create table grant underscore programs, granted int references grants, ID, programmed int references programs, ID, create table name deans a new table called name in SQL. Within each command is a list of ELD names and types. Example ID integer indicates that the table contains a ELD named ID with type integer. Each ELD definition may also be followed by one or more modifiers, such as primary key, indicates this is a part of the primary key, i.e., is a unique identifier for the row. Implies not null. Not null, indicates that this ELD may not have the special value null. References, indicates that this is a foreign key which references an attribute, i.e., column, in another table. Values of this ELD must match, join, with a value in the referenced attribute. Databasehomeworkhelp.com. Phrases following the dash dash in the above table definitions are comments. Notice that the above tables reference each other via several foreign key relationships. For example, grants are administered by an organization, as denoted by the line org int references orgs, ID. Note that there are three many-to-many relationships, between grants and researchers, grants and ELDs, and grants and programs. In SQL, these many-to-many relationships are represented by additional tables, example grant researchers, which is why there are 6 distinct entities but 9 SQL tables. 3. Connecting to the database. We have set up a database server for you to use on hancock.csale.mit.edu. To connect to the database on Hancock, you will need the PSQL Postgres client. Type the following, assuming PSQL is in your path: PSQL hancock.csale.mit.edu P5432 6832 2010 Username is your Athena * username that you signed up with on our sign-up sheet, or if you don't have an Athena * username, the part of the email address that you gave us prior to the @ sign. If you are unable to log in, please let us know. Currently, the database only permits incoming connections from an MIT or XALE machine, and we would prefer you use a machine within MIT, example an Athena * machine, to connect to the database and run queries, if possible. If you need to use a machine that's not within MIT, you can use MIT's VPN software at http://ist.mit.edu/services/network/VPN, or you can use an SSH client to log into linux.mit.edu and run the PSQL client from there. Databasehomeworkhelp.com. * Follow the prompts, and type your Athena password again if prompted. After running this command, you'll be able to use PSQL until you log out. Your computer, you may also connect to the database using PSQL installed on your local computer. In general, it can be installed through the PostgreSQL or PostgreSQL client package in a package manager program, such as apt or yum for Linux, Mac ports for